What is parallax? If you look at this animation, you will notice that the mountains in the front are moving much faster than the mountains in the back. This effect is called parallax. We can use parallax to measure the distance of the stars. As planet Earth orbits around the Sun, the stars appear to shift side to side relative to more distant stars. The farther away a star is, the less it moves. This shifting is very small. Looking at a star, for example in January, and then looking at the same star again in July, we can draw a triangle. The base is the diameter of the Earth's orbit. The opposite angle is how far the star appears to shift. Using simple trigonometry, we can calculate the triangle's height, which is the distance of the star.
What is the Doppler effect? It is the change in frequency of sound, light, or other waves as the source and the observer move towards or away from each other. If we observe stars, we can see that they are moving away from us, causing a red shift. The amount of redshift a galaxy exhibits, Z, allows us to calculate how fast it is moving. This can be done using measurements of either wavelength or frequency changes. This is also what Hubble's law is. All objects in deep space have a Doppler shift measured velocity relative to Earth and to each other. The Doppler shift measured velocity of galaxies moving away from Earth is proportional to their distance from the Earth and all other interstellar bodies. As virtually all galaxies show redshift in their spectra, Hubble concluded that all galaxies must be moving away from each other. Therefore, the universe must be expanding.
Knowing the distance of a star and its velocity, we can measure the time taken for it to get there. Since every interstellar body in the universe is moving away from each other, we can say that Earth is the center of the universe. Therefore, the time taken must be the age of the universe. This next calculation uses Hubble's constant. From this simple calculation, we found out that the age of the universe is around 13.7 billion years. What is the ultimate fate of the universe? Will the universe keep expanding, or will it stop? To find the answer, we need to know the total mass of the universe and more specifically, the density of the matter. Gravity is the force that can slow the expansion to a stop and may even start to cause the universe to contract inwards. This might eventually end in a big crunch. If the matter in the universe is scattered, then the gravitational forces between particles, stars, and galaxies will be generally weak. The universe will be expanding forever. However, if the matter in the universe has more than a critical density, then the gravitational forces will be able to cause the big crunch, thus ending the universe. Galaxies emit a certain amount of light. We can measure this by measuring their apparent brightness and accounting for the inverse square decrease in this caused by the distance to the galaxy. From the actual luminosity of a galaxy, we can estimate the mass of all the stars in it. Galaxies rotate, and this means that all the stars they contain must be experiencing a centripetal force towards the center of the galaxy's rotation. When the astronomers measure the rotational speed of the stars in the galaxies, they find that the mass suggested by the luminosity calculations is not nearly enough to create the centripetal force needed to keep the galaxy spinning. This means that galaxies contain a lot of mass that does not emit light. This is what dark matter is.
If light cannot escape me, what hope have you?